Okay, we're ready to do the second half of section 4.1. This is the section on solving systems of equations. As I promised last time, we will be learning two other ways to solve systems of equations. The second method is called solving by substitution. First we did solving by graphing. So let me just show you how this works. You have two equations, and instead of graphing them, we're going to use this substitution method. This happens to be a problem that we did just a few minutes ago with a graphing technique, so we already have seen the answer to this. We take the first equation and we solve it for one of the variables. Let's go ahead and leave the x over here and bring the y across. So x is equal to 4 minus the y, okay? This is what we want to use for our substitution. So we're going to go into this equation, and where there's an x, we're going to replace it with what x is equivalent to. So I take the x minus y equals 2, and I replace the x with what x is equivalent with. 4 minus y equals 2. So I have 4 minus 2y equals 2. So negative 2y equals, we subtract 4 on both sides, divide by negative 2, y equals 1. Okay, now find x. X is 4 minus y. And now we know that y is 1. So x is 3. In other words, 3, 1 is the solution to this system of equations. If we had graphed it, which we did a few minutes ago, let me see if I can put my hands on that graph. If we graph it, those two lines will intersect at 3, 1. Do you remember this first example we did a few minutes ago? And they intersected at the point 3, 1. So we've now solved this with two methods, and that's nice. Okay? Okay, now let's do another one of this type. See what else can happen. Number 3b, and 3c, I'm going to skip to part c. Y equals 3x plus 8 is the first equation, and 12x, that should be a negative 3x plus 8, and 12x plus 4y equals 32. So the good news is that the first equation is already solved for y. So I can take y and replace it with this. So I'm going to go to the second equation, 12x plus 4, there's the y. And I'm going to change the y to this, negative 3x plus 8. Notice that when we substitute, we go from having two variables, two unknowns, to one unknown. And that's easier for us to solve because it's just a simple equation. So let's go ahead and multiply this. We have 12x, 3 times negative, that'll be negative 12x. 4 times 3 is 32. 12x minus 12x is 0, so I have 32 equals 32. Remember, sometimes when you get something that's always true, then it's going to work for every point that would be on this line. These lines, in fact, when you graph them, they're going to land, they're the same line, right? They're going to be the same line, both of those. In fact, this is just a multiple of that line. Okay, they're the same line. So the solution is the set of all x, y points where they are on this line. Any point on this line is also on that line because they're the same line. So all the x, y points that are on the line. You can't just say any real number because there are numbers when you graph a line, okay, wherever in the heck it is, there are lots of points that aren't on that line, right? So you have to pick a point on that line in this case. There we go. Okay, so the third method that we need to cover, we'll do a bunch of these because this is really a very good method. The third method is called elimination. When you eliminate something, you get rid of it, okay? And in some ways, substitution does that because it gets down to one variable, but this is going to work a little differently. So the first example, well, here we go again, the exact same equation that we did first with graphing, And the one we did first was substitution. Okay, so the way elimination works is that you can multiply each equation by something, but you ultimately want to add and subtract, add or subtract the two equations to eliminate one variable. So if we wanted to add or subtract these, notice if we just simply try to add these two equations, so that's the number of the problem we're working, so kind of ignore that. If we just add these the way they are, okay, we can add them. If they're equal and we add them together because of the properties of equality, it's still going to be equal. X plus X will give us 2X. Positive Y and negative Y make 0Y, so we eliminated the Y. And add the 4 and this 2 and we get 6. So by adding these two together, we wanted to eliminate one variable and we did. So now we can find out, divide by 2, that X has to be 3. So for the ordered pair to solve this, the X is 3. Now to find out Y, we're going to pick either one of these and we're going to let X be 3 because that's what it is in this problem, okay? So subtract by 3, subtract 3, and Y is 1. So these two lines cross at the point 3, 1. And we know that because we saw it before with graphing and with elimination. I mean with substitution and now with the elimination. So 3 different ways to work the same problem. And there may be problems on your quiz or on your next test that will tell you to use a specific method. So you need to be able to do all 3 of these methods. There are certain times that one is preferable over the other. Okay, let's go ahead and try the second example with elimination. That would be 4B. And it says that X minus 6Y equals negative 9 and 8X minus 6Y equals negative 30. Okay. Now, if we add these together now, we're going to get 9x, negative 12y, so we didn't eliminate anything. In order to eliminate something, you need what are called opposites, right? They have to be the same number but opposite signs. So the opposite of a negative 6 is a positive 6. So I wish that one of these was a positive and one was a negative, okay? The opposite of 8 would be negative 8, so it's easier to take care of this opposite. So I want one of those to be a negative 6. So I'm simply going to take this first equation and multiply the whole thing by negative 1. So it's going to give me negative x plus 6y equals positive 9, right? Because it changed the negative to positive, switched all the signs. And now I'm going to copy the second equation just the way it is. And when I learned to do this, we put lines in between the steps, okay? Now, if I add these at this point, I should be able to eliminate something because I have opposites, additive inverses, opposites. So I add this and I get 7x, 0y's equals 21, and it's negative, and we want to divide off the 7. So x is equal to negative 3. Okay, so now I know that when I look for the point that these are going to intersect, it's going to be x is the negative 3, and now I need to find y. So I'm going to take the first equation at the very top of the page, 8 minus 6y equals negative 9. How did I know which one to pick? It doesn't matter. If the point is on both lines, you could pick either one of the lines. So I picked the one that had smaller numbers in it. Okay, that was my plan. Now I'm going to put negative 3 in for the x. Add 3 on both sides. And y equals 1. Negative 3, 1 is the intersection point for those two lines. Okay? Now you see how this method is working. I'll let you look at that a second before I move it. Okay, good. If you graph them or if you used substitution, you would get the same solution. There's your solution. Okay, let's go on to number 4C. Okay, 4C. It has the line x minus 4y equals negative 8. And negative 6x minus 3y equals negative 6. Okay, I'm going to double check that I copied that correctly. Looks good. Okay, now to eliminate things, we have to have additive inverses, which are opposites, right? The opposite of negative 6 is positive 6, so I could get a positive 6 there. Or I would have to have a number here to eliminate. Well, in order to do that, I would need probably a multiple of these. 4 times 3 is 12. I would probably need to make this a negative 12 and that a positive 12. That sounds like too much work. I'm just going to try to get, my plan is to get a 6 in front of this so that I'll have the opposites there and get rid of my x's. Okay, so I'm going to multiply the first equation by 6. So I get 6x minus 6 times 4 is 24, y equals 6 times 8, negative 48. Now I'm going to copy the second equation just the way it was. Okay, now I'm going to add these together, and I get 0 x's, good, I eliminated with the elimination method, that's what we want. I get negative 27y is equal to, okay, 48, 54, and that's a negative, right? Negative and negative makes a negative. Now I'm going to divide negative 54 by a negative 27. That should be 2, positive 2. So for my solution, and I'm going to go ahead and write the solution right here. Be careful, the y this time is 2. So we're starting out knowing the y. Now we need to find x. So again, pick the easiest looking equation. That's the very first one I had at the top of the page. In my opinion, it's that one right up there. And I'm going to put 2 in as the y. Okay, x minus 8 equals negative 8. I'm going to add 8 on both sides. Get x equals 0? Oh well, some graphs cross at 0 something, 0, 2 in this case. So there's the solution. There's where those two lines would intersect in a graph. That's the point that satisfies both. Okay, let's do another one. Building up to the harder ones on these. I'll probably give you an easier, medium level one on your test. Part D. 3x plus 6y equals 3. 2x plus 9y equals negative 8. Good. Okay, this doesn't look great, folks, because we have the positives in front of both of them, and to be additive inverses or opposites, they have to have opposite signs, so we've got to have a negative somewhere, and we don't have one. And things aren't going to cancel out very well yet, because 3 and 2 don't cancel, and 6 and 9 don't cancel. So in this case, we need to get a multiple of those. We need to multiply by something. So if I had a positive 6 and a negative 6 in front of these, then I could solve it from there. So that's my plan, is to get a 6 and a negative 6. So I'm going to multiply the first one by a negative 2. That will make a negative 6x. And I'm going to multiply this one by a 3, and that'll make a positive 6. So then I'll have a negative 6 and a positive 6. That's my plan. So negative 2 times the first one gives me a negative 6x. Negative 2 times 12. Negative 12. Sorry, negative 2 times 6 is 12. Oh, goodness. And we get negative 6 over here. So I multiplied by a negative 2. Good. And now I'm going to take the other equation and I'm going to multiply it by positive 3 the whole way through. It gives me 6x plus 27y equals negative 24. Okay. Now, if I succeeded, when I add these together now, I should eliminate something. And I did succeed because I got a negative 6 there and a positive 6 there. Again, I just picked the least common multiple of those two numbers. You could have done it right here with these, but I think those are smaller and easier to work with. Okay, so I'm going to get 15y equals negative 30. And I'm going to divide both sides by the 15, and I get negative 2. So for the solution for this, y is negative 2. Now I have to figure out what x is. So here's my solution. I always just stick the point up here. Now find x. Pick any equation, and usually that first one of the first ones is the easiest. So I'm going to take 3x plus 6y equals 3, and I know that y is negative 2. So I put a negative 2 in. 3x minus 12 equals 3. 3x equals, add 12 on both sides, 15. X equals 5. Yes, x is 5. So the point 5, negative 2 is where these cross. Looks good. Okay, let's do another one. I'm going to have this system down by the time I'm done with all these examples. All right, let's do for E. And my equations are 6x minus 8y equals 8 and 12x equals 16y plus 24. This second one isn't lined up very well, is it? Okay, so the first thing I'm going to do is just rewrite this a little better. I have a 6x minus an 8y equals 8, and I'm going to line these up. I want the 12x, I'm going to subtract the 16x and bring that over, 16y, pardon me, I said x, and the 24 leave alone. Now things are lined up better, and that helps. Now we have to decide what do we want to eliminate, and I say let's work on x. This has a 12, and I could have this to have a negative 12. So I would need to multiply by a negative 2 to make a negative 12 there. So I'm going to take that first equation and multiply it by a negative 2. That'll give me negative 12x, positive 16y, and a negative, see, 2 times 8 is 16. Okay? Good. Now I copy the second equation just the way it is. And I'm going to go ahead and add these at this point, and I eliminate my x. I have 0 x's now, and I eliminate my y's, so nothing on this side, right? And this side is 24 minus 16, 8. Do y'all believe that 0 equals 8? No. When you get something that's stupid like this, you say there is no solution. Okay? No solution. And in many cases, they're going to give you this symbol that means null or nothing or no solution. Good. So that's one special case. What's the case going to look like if you graph it? These are going to be parallel lines that never cross, so they have no common points. Okay? Make sense? Good. All right, and our final example will be for F, and it goes like this. Negative 6x minus 4y equals negative 2, and negative 12y, equals negative 6 plus 18x. Ugh, I don't know why they don't line these up for us, but oh well. Let's double check that I copied this correctly. Yes. Good. Okay. Always make sure if you have a tendency to miscopy things that you don't do that, because I have that tendency. It's not uncommon at all. Okay. Now I'm going to have this lined up x, y numbers. So I'm going to leave the first one just like it is. Okay, now I want to bring this x over, so I subtract the 18x on both sides. So I'm going to have a negative 18x, and then the negative 12y equals, and the negative 6 will sit over here. Okay, now we would like to eliminate something. So I could deal, these are smaller numbers, so let's get a 12 in front of both of these. This needs to be a negative 12, and that needs to be a positive 12. So to get this to be a positive 12, I'm going to have to multiply the first equation by a negative 3, because that'll make a negative times a negative will give me a positive. So I'm taking the first equation and multiplying it by a negative 3. Negative 3 times 6, negative 8 is negative 3 times negative 6 is positive 18. Negative 3 times negative 4 is positive 12. Why? Negative 3 times negative 2 is positive 6. Ugh. Okay, we did it. Now let's copy the second one. Don't even think, just copy. And now go ahead and add. Let's see if we eliminate that y. Uh-oh, we eliminated the x. We eliminate the y. And we get a 0. And on this side we get a 0. Now that's different from what we got before. Last time we got 0, this was stupid, right? It didn't make any sense at all. We said there's no solution. This does make sense because 0 does equal 0. What this is telling us is that when we graph these two lines, I don't even know what their slope is, but they're going to land on top of each other. So this is going to have all the solutions that are points on the line will solve this system. So it's going to be every point x, y where it's on the line. Just pick either one of those lines. Let me make sure that's the way they're writing it. Yes, it's exactly how they're writing it. Okay. So any point on one line is also on the other line because we get something that is obviously true. So it's going to be true for all, we can't say all real numbers again because we can only say all points that are on the line. All right. I will see you very soon. No more recorded lectures for a while. Hope you've been doing well and keeping up with your My Math Lab. Good luck. Bye.